All right, Chapter 5, Lesson 1, Solving Systems of Equations by Graphing. Before you can learn how to solve a system of equations by graphing, you have to know what it means to solve a system of equations. So the last chapter, Chapter 4, what we did was y'all learned how to graph equations and how to write equations of lines, okay? So in order to really graph a system, what we have to have is we have to have our equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So the y needs to be by itself, the x needs to be first, and then the whole number at the end. All right? So we want all of our equations to look like this, and in the beginning, I'm going to give them to you like that so that you can practice, or so that you just already know it. But as we go through this lesson, we'll get to ones that you're going to have to get in slope-intercept form first before you can actually graph the equation. So essentially, we're going to be given equations to graph, okay? So that's your first step to know, is that we're given equations to graph. To solve them, what that means is you're finding where two lines, two equations, are intersecting, okay? That point, remember a point is made up of an x and a y. That point is your answer, okay? So you're not going to get just one number, you're going to get two numbers, the x and the y, and you'll put it together in a point, just like that. So we're going to graph these equations, and then we're going to see where they cross each other, all right? And our answer will be that point where they cross. All right, so solving a system of linear equations by graphing. The reason that they're specifically saying by graphing as well is because there are three different ways to solve a system of equations. This is the first way. The first way is by graphing. We'll learn the other two as the time goes on, but for right now we're going to focus on graphing. All right, so solving a system of linear equations by graphing. Step 1. Okay, so step 1, you need to write these in your notes. Step 1 is to graph each equation in the same coordinate plane. So what that means is, you should have your graph paper. You're going to draw one x-axis and one y-axis. Okay, just like we did when we graphed earlier. And you're going to graph both lines in this same spot. So you're not going to do two graphs. You're going to do two lines in one graph. So one of them might be here and another one over here. Because if we put them together like that, we'll now be able to see, hey, here's where they intersect. That's my answer. Okay? Step 2, estimate the point of intersection. A lot of times we'll be able to get the exact point because it'll be on a corner and we'll know for sure what it is. But sometimes it won't be on an exact point. Sometimes it'll be a decimal. So that's why they say estimate. Just guess as close as you can. You're not going to be able to get an exact decimal by looking at a graph. All right? So if it looks like it's 0.7 or 0.6 or 0.8, I mean, all of those are really close together. So I'm not going to count off if you have one of those three. Now, if it's supposed to be 2.7 and you put 1.7, yes, I'm going to count off. All right, because that's a big difference. And step 3, check the point from step 2 by substituting for x and y in each equation of the original system. And I'll show you how to do that part once we get to it. By checking if that point works, and if that is where they cross, then I'll be able to plug in x and y, okay? Because remember, we're going to be given equations that say like y equals 2x plus 4. And we're going to get a point that might be 3, 5. If that point is correct, all right, then I should be able to plug those numbers in for x and y and get a true statement. So let's just see if this one would work. So I plug 3 in for x and 5 in for y. So y, which is 5, equals 2 times x, which is 3, plus 4. All right? 5 equals, well, 2 times 3 is 6. Okay? 6 plus 4 is 10. 5 does not equal 10. So what that tells me is that that point, 3, 5, that I got was wrong. Now, I'm not actually working a problem right now. I'm just kind of giving you examples of kind of what it's going to look like. If that had actually worked and was correct, instead of a y of 5, I would have gotten y of 10. And then it would give me a true statement, and then I would have known, hey, that worked. But it'll make more sense in just a little bit once we actually start applying this to real problems, all right? So just bear with me if you're still a little lost. All right, so number 1. Okay, so you should have graph paper. Go ahead and draw your graph on here. And I'll have mine. Maybe. Insert. I always forget how to do this. Tools. View. Customize. There it is. Down here. There it is. Grid Designer. Add. Okay. Done. Alright, so I'm adding my graph. Make it a little bit bigger. Okay, so don't forget your X and Y axis. Alright, so equation 1, I'm going to do in red. Okay, so I'm going to go ahead and graph it. Now, let's review how to graph an equation. Again, it has to be in slope-intercept form. Okay, remember slope-intercept form is y equals mx plus b. M is your slope and b is your y-intercept. So having a slope of m, it tells you where to go. B tells you where to start. Okay, so looking at my first equation, y equals 2x plus 5. 2 is my slope. 5 is my y-intercept. Remember, we start there, right? We start at the y-intercept. So I'm starting at 5. It's the y-intercept, so I'm going to 5 on the y-axis. I'm actually going to make my graph a little bit smaller. Move my... Alright, so I'm going to go to 5 on the y-axis. So 1, 2, 3, 4, 5. Alright, and now I'm going to use that slope. Remember, slope is rise over run. And our slope is 2. Remember, put it over 1. 2 over 1. So I'm going to rise 2, so that means I got to go up 2 and over 1 to the right 1. Now, this is why I taught y'all that it was important to get into a habit of going up and then going backwards. So you go back to your y-intercept, and instead of going up 2, we're going to go down 2, instead of to the right 1, to the left 1. Okay? Now, I'm not extending it a whole lot, and that might be where we have to go back, and this is really good to do. If you have markers or colored pencils, I would encourage you to use different colors on these so that we can tell which graph is which. Because we might have to extend our graph even more. We may have to do another up 2 over 1 or down 2 over 1. We'll just have to see because we need them to intersect. We need them to cross. Alright, so now I'm going to do equation 2. I'm going to do it in green. Okay, so equation 2, y equals negative 4x minus 1. Negative 4 is your slope. Negative 1 is your y-intercept. Okay? So remember, we start at the y-intercept, so I'm starting at negative 1. I'm doing my slope. Remember, it's rise over run, and this is a whole number, so we put it over 1. So it's negative 4 over 1. Well, I can't rise negative 4. The negative simply tells me to go down. So I'm going to go down. 1, 2, 3, 4. The 1 on bottom is positive, so I'm going to the right 1. Remember, we want to do the same thing, but backwards. So I go back to my y-intercept. Instead of going down 4, I'm going to go up 1, 2, 3, 4. Instead of to the right 1, I'm going to go to the left 1. Okay, and you'll see right there, we just intersected with the red line. Okay, so I'm not going to need to extend my graph out on either of those. All right, so basically, I just found my solution, okay? Now, the answer is not the graphs. The answer is not pointing to that point. The answer is the point. So you have to actually tell me what that point is, okay? Remember, a point is made up of an x and a y. So when you go to this point right here, first I want to know what is the x. Where does it line up on the x-axis? It lines up right here, okay? And then where does it line up on the y-axis? So on the x-axis, it lines up at -1. On the y-axis, it lines up at +3. So my answer is -1, 3. So yeah, that was a lot of work to get to that. But this is our first form, okay? So you'll get faster. I'm just going through each step. So on these next problems, what I'm going to do is I'm going to put them up. You go ahead and press pause. All right, you press pause, and you try and work it yourself. If you get stuck, press play. Okay, press play and see if you can get to where you're getting stuck at, and then keep going. All right, if you can't figure out what I'm doing and you're just completely lost after watching a couple more problems, call me over, and I'll help you as much as I can. All right, but let's go ahead and keep going. Oh, actually, before we do that, we need to check that answer. As I told y'all we would check these answers to see if they worked or not. So again, to see if an answer works, you plug it back in. So we've got two equations here. First one is y equals 2x plus 5. If this point, -1, 3, works and is the correct answer, I can plug it in up here for y and x. So remember, x is -1, y is 3. So instead of y, I'm going to put 3 equals 2 times x is -1 plus 5. 3 equals 2 times -1 is -2. 3 equals, and -2 plus 5 is 3. Does 3 equal 3? Yes, it does. So it checked on that one. But I also have to check the second equation, equation 2. Okay, so I'm going to take that and I'm going to plug it into equation 2. Y equals -4x minus 1. I'm using the same x and y, that same answer we got. We're just checking our answer. Instead of y, I'm going to put 3 equals -4 times, instead of x, I'm putting -1 minus 1. -4 times -1 is +4. And 4 minus 1 is 3. So again, 3 does equal 3. So it worked for both equations, which means, yes, that is the correct answer. So there is a way to check yourself and make sure that you got it correct. It could be a case of you accidentally put 1, 3 instead of -1, 3, right? You just read the graph wrong. But this is a way to kind of double check that. All right, let's do the next few problems. Okay, so again, I want you to go ahead and start number 1. If you're not feeling comfortable yet, go ahead and work this one with me as well. But at least on number 2, I want you to press pause and try it yourself, and then check your answer with mine. All right, number 1. Go ahead and put my graphs up. All right, I'm going to do the first one in red, and the second one in green. Again, if you've got colored pencils or something, please do that. If you don't and you would like to use some markers or colored pencils, ask me. I probably have some in a drawer somewhere. All right, so the first one, my slope is 1 over 1, and my y-intercept is -1. So I got to go to this y-intercept first, -1, and then I do my slope. Rise over run, so 1 over 1, up 1, over 1. Then I go back to the y-intercept and do the same thing backwards. Instead of up 1 over 1, I go down 1, and then to the left 1. All right. Switch to my green one. Slope is -1 over 1. Y-intercept is +3. So remember, we start at the y-intercept, +3. Slope -1 over 1. Remember, the negative tells me to go down, so I'm going to go down 1, but instead of to the left, because my 1 on the bottom is a positive, and positive means right. Go back to your y-intercept. Instead of down 1, I'll go up 1. Instead of to the right 1, I'll go to the left 1. All right, and so what you're going to notice here is these two did not intersect yet, okay? You can see that they are going to intersect, right? We just don't have it drawn that they're going to intersect. So what we're going to have to do is I'm going to go back to the red one, and I'm going to extend it some more. So I see that it's going to intersect in this direction, right? I'm not going to extend it this way. That's going away from the green line. I want to extend it towards the green line, all right? So I'll see here, to keep going, I go up 1, over 1, up 1, over 1. I'm just going to do it twice just to be safe. Now go back to the green. They're still not intersecting. So go back to the green. Remember the green one, the slope is down 1, over 1. And look at there. There's our intersection. So sometimes you're going to have to keep extending that graph out, and then you'll get your answer. But again, I don't have the answer written down yet. The answer is a point, the x and the y. So I look at this point, and I go straight down to the x, and I mark it. Go back to the point, go straight over to the y-axis, and I mark it. Remember, x goes first. The x, 1, 2, and the y is 1. So my answer is 2, 1. Remember, we can check these. So for the first one, nope. Instead of y, I'm going to put what y is, which we got 1. Instead of x, I'm putting what x is, which we got as 2. And 2 minus 1 is 1. So the first equation checked out. I'm going to check the second equation. Y equals negative x plus 3. Okay, instead of y, we're putting 1. Instead of, and then negative, and instead of x, we're putting what x is, which is 2. Well, negative 2 plus 3 is 1, so that one also checks, so I know my answer is correct. All right, again, if you've got any questions, you're not sure what I did on anything, please call me over. We're going to keep moving to number 2. Again, I want you to try this one on your own, so press pause, and then check it by pressing play. Alrighty. Move this over. Red, green. Ooh. Now I may not have enough room on this one. So I'm actually going to make my graph a little bit smaller so that I do have some room. So I'm going to go 14. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm actually going to move this down some maybe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now my slope is negative 5 over 1, so I need to go down 1, 2, 3, 4, 5 to the right 1, up 1, 2, 3, 4, 5 to the left 1. So you may have to draw a big graph for this one, that's okay. Then for the second one, slope is 1 over 1. Y-intercept's negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cutting it close on this one. Slope is 1 over 1, so up 1 over 1. Now, I don't really have a lot of room to go down 1 over 1, but I can see that this graph's going down, this one's going up, so they're going to meet somewhere over here, right? So I'm just going to keep going up 1 over 1. And I think that's probably going to be pretty far. We can already kind of tell it's going to hit one of these already. Now I'm going to go back to my red because it hasn't hit it yet, right? I'm going to do that slope again. Remember the slope was -5/1. So down, 1, 2, 3, 4, 5 over 1. Still haven't hit it. Down, 1, 2, 3, 4, 5 over 1. Still not there. 1, 2, 3, 4, 5 over 1. And there we are. Okay, so again, my answer is where they intersect. So I go this all the way up to the X, mark it, all the way to the Y, mark it. So remember X is first, so that's 1, 2, 3, 4. -1, 2, 3, 4, 5, 6. And that should be my answer. So I'm going to go over and check it. -6 equals -5 times 4 plus 14. -20 plus 14, which is -6, so that one checks out. And then we check out the second one. -6 equals nope. 4 minus 10. 4 minus 10 is -6, so that also checks. So my answer is correct. All right. Okay, again, call me over if you just didn't get that right and you're not sure where you went wrong, okay? Now, when you ask me where you went wrong, like, I got to see some work. I got to see what you did, all right? Number 3. Again, press pause, see if you can do it by yourself. Y equals X. Slope, remember, is the number in front of X, so 1 over 1. Y-intercept's the number by itself. There is no number by itself, so the number equivalent of nothing is 0. Go ahead and do my green. Slope is 2 over 1. Y-intercept is 1. All right, so for the red one, 0, and probably make it bigger now. 0 is where I start, and my slope is 1 over 1, so I go up 1 to the right 1. Go back and I go down 1 to the left 1. All right, and then the green. Y-intercept is a positive 1. My slope is 2 over 1, so that's up 2 over 1. Down 2 over 1. So you see, if we hadn't gone backwards, we might not have seen where they intersected right there. So again, remember, our answer is that point. You have to write the point down. So I'll match it with the X and the Y. The X is -1, and the Y is -1. Now we can go back in and check it. Y equals X. -1 equals -1. Check. Y equals 2x plus 1. -1 equals 2 times -1 plus 1. -2 plus 1. Check. So our answers are correct. All right, let's keep going. All right, so these, you'll notice, they don't all have Y by themselves, right? So we're going to have to get a few of them where Y is by itself, and we're just going to do a couple of these. We'll just do all of them. All right, so number 4. When I look at the first one, Y is already by itself, so we're good there. I can already tell you what the slope is and what the Y-intercept is. But when I look at the one underneath it, Y is not by itself, right? Y is not by itself here. So I can't immediately look at it and say what slope is and what Y-intercept is. We have to get Y by itself. Well, what's keeping Y from being by itself? The plus X. And how do I get rid of a plus X? minus x. All right, so this plus is just basically saying that the y is positive. Now, 2 minus x, apples and oranges. You cannot subtract an x from a 2. All right, you can multiply them, but you can't subtract them. You can't add them. So 2 minus x is 2 minus x. But here's the problem. In slope-intercept form, it's y equals mx plus b. The x always comes first. So we need to reorder this. I need the x to be in front. Now, this minus is also a negative that goes with the x. So I'm not just moving the x in front and switching the numbers around. I have to move the sign with them. So that's negative x, and this is technically a positive 2. So plus 2. Now, y is by itself, and I can immediately look at it and tell what the slope and y-intercept is. Slope is negative 1 over 1, y-intercept is 2. Okay? So now that I have all that information for both of them, we can graph it. Okay, so from our red one, y-intercept's negative 7. I have to make my graph smaller. Okay, so y-intercept's negative 7, so I go down 2, 3, 4, 5, 6, 7. And the slope's negative 4. Remember, that's negative 4 over 1, right? So it'd go down 1, 2, 3, 4 over 1. We go back to the y-intercept and go up 1, 2, 3, 4 over 1. Okay? Now I'm going to do the green. Y-intercept on the green is 2. And do my slope of negative 1 over 1. So down 1 to the right 1. Go back, up 1 to the left 1. Alright, so they have not intersected yet. But it looks like they might at some point, right? So I'm going to go ahead and extend this red one. They're not going to meet anywhere down here, right? They're going inward this way. So they're going to meet somewhere over here. So I'm going to do this slope. So to go from here to here, I went up 1, 2, 3, 4 to the left 1. So I'm going to go up 1, 2, 3, 4 to the left 1. Up 1, 2, 3, 4 to the left 1. Okay? That might be close enough. It's pretty close to that green line, right? But they still haven't crossed, okay, with an actual point. Just because you've extended your line out doesn't mean anything. They have to actually have a point that crosses each other. To go to my green, the slope on the green is 1 over 1. Okay, so to go from here to here, I went up 1 and to the left 1. So I'm going to go up 1, left 1. Up 1, left 1. So now I have 2 points on top of each other. There's the x. There's the y. 1, 2, negative 3. 1, 2, 3, 4, 5. And there's my answer. And you can check it just to make sure that you got it right. But I'm going to skip that part because that's just for you. If you want to check it, you can check it. I'm not going to make you check them. But that's a guaranteed way to know if you got it right or wrong. All right. Number 5. Okay, when you look at number 5, you'll notice that neither of them have y by themselves, right? So I can't look at either of them and decide what is the slope and y-intercept. So first thing I'm going to do is I'm going to get y by itself on this one. So we've got negative y and x. So the x is keeping y from being by itself. So first I got to get rid of a positive x. So a minus x. Remember, this minus is the y, part of the y, right? Okay. So now we've got negative y equals. Remember, we want our x to go first. So instead of putting 5 minus x, I'm just going to go ahead and put the x first and put negative x. Since it's a positive 5, I'll put plus 5. All right, now. We don't have y by itself. That y still has a negative attached to it. To get rid of a negative, the easy thing to do is to just change everything to its opposite sign, right? The opposite of a negative is a positive y. Opposite of negative x is positive x, and the opposite of positive 5 is minus 5, or negative 5. So now we've got y equals x minus 5, where the slope is 1 over 1, and the y-intercept is negative 5. And now we look at the second equation. I see that this one also does not have y by itself. Well, the only thing keeping y from being by itself here is that negative 3x. So to get rid of a negative 3x, we would plus 3x. So now I've just got y equals, again, we know the x needs to go first. I'm going to go ahead and write the x first. The plus is really just telling me it's a positive, so I'm just going to put 3x minus 1. So y is by itself. I can now look and say, okay, m equals 3 over 1. Y-intercept is negative 1. And now we can graph. We'll raise this up some. Alright, so let's do the red one first. Y-intercept is negative 5. And the slope is positive 1 over 1. So up 1 over 1, down 1 over 1. Alright, and then the green one. Y-intercept is negative 1. Slope is positive 3 over 1. So that's up 1, 2, 3 over 1. Down 1, 2, 3 over 1. They have not intersected. Okay, so what I'm going to need to do is I'm going to extend the red one and the green one. They're obviously going to be going this way, so I'm going to extend the red one, so I'm going to go down 1 over 1. And then the green one. Remember, the green one was down 3 over 1, so down 1, 2, 3. And there you have it. They cross right there. Negative 2, 1, 2, 3, 4, 5, 7, negative 7. Alright, so we're going to stop there. You should have enough problems to really kind of help yourself and know what you're doing. Again, if you have a question about something, ask me. Now head on to Schoology to the next assignment, the next thing that you're going to do for practice on this.